So these next two problems are pretty much exactly the same. So I'm going to do the first one. I'll do the second one in my notes, and I can scan it when I upload my whole notes, and that way you guys can see it. But they're pretty much the exact same question, and I mean the numbers are pretty similar as well. So find all solutions to tangent of 3x for values of x measured in radians. So first thing I want us to notice that it's all solutions, okay? And that we are not given a like restricted domain. In the previous problems we saw like between 0 and 360 or 0 and 2 pi. We don't have that here. So a couple of things. We'll go through these steps that we've been kind of doing. We have 3 rotations technically, but we're going to kind of see that it's not really going to matter in this problem, and we'll kind of see that at the end when we write our answer. So number 2, there's no domain. They don't give us a domain, but we want to find all solutions in radians. So what that tells me is that I'm going to add this 2 pi k at the end of my answer. Okay, so we don't have to adjust the domain or anything like that. And step 3 is just going to be solve. So tangent of 3x is equal to 1. Tangent inverse of 1 is equal to 3x. So tangent is positive in the first and in the third quadrant. Okay, it's 1 when sine and cosine are the same, and that happens at your pi over 4s. So pi over 4 in the first quadrant is pi over 4. Pi over 4 in the third quadrant is 5 pi over 4. All right, now I am not going to find the second or the third rotation because this 2 pi k is going to take care of that for me. Remember, when we add 2 pi k or 360k, that says go around the unit circle as many times as I ask you to, k times. So by adding this 2 pi k, we're going to get those 3 rotations. So I'm just going to set these two equal to 3x, solve for x, and I'll show you how we write our answer. So we have pi over 4, 5 pi over 4 is equal to 3x. We divide everything by 3, looks good. We'll get pi over 12, and 5 pi over 12 is equal to x. Now, that's not quite our answer yet. Our full answer is going to be pi over 12 plus 2 pi k and 5 pi over 12 plus 2 pi k. Okay, these are going to be our answers. These 2 pi k's are ensuring that we get as many rotations as we need, and these are the 2 angles we start off with. So it actually is a little bit easier than the ones that we have done in the past. So the rotations are important just in terms of what you set it equal to, in that terms of 3x or in the second one 2x. There's no domain, but we got to add that 2 pi k. And then we solve, but we only solve for the first rotation because that 2 pi k is going to take care of all the other ones. All right, like I said, I'll do this one in my notes, but they're very, very similar, and I think you guys will see that. So the other example I have on this page is the sine 2x cosine x plus cosine 2x sine of x is equal to root 2 from 0 to 2 pi, including 0, not including 2 pi. Now, before you start being like, oh my God, what does this all mean? All right, if it looks pretty awful, that probably means that there's an identity to make this better, and there is, all right? And you may not have this off the top of your head yet, but this actually is the sine sum and difference formula. Sine of a plus b is equal to sine of a cosine b. We swap the trig functions, keep the SIGN sign, sine of b cosine of a. This looks exactly the same as that. And in fact, I can label 2xa and xb. So a is going to be x, b is going to be, a is going to be 2x, b is going to be x. So I can say something like sine of a plus b is equal to sine of 2x plus x, or just sine 3x. Which is very exciting because that means that whole left side of this problem reduces down to sine 3x. And this turns into something we can actually do. These are the problems that come up in this section. All right, so we are given a domain here. So first off, we want to talk about the rotations. There's 3 rotations. Obviously, the more rotations, the more work. So you could have as many rotations as you want, but 2 or 3 are pretty standard. All right, so now we talk about domain. So because it's 3 rotations, our original domain is x. So I'm going to multiply our domain by 3 and get 0 to 3x to 6 pi by multiplying this domain by 3 because we have those 3 rotations. That's what I'm going to check to make sure my x's get all done and solved with. All right, and then we're going to solve this. So sine 3x is equal to root 2 over 2. Sine inverse of root 2 over 2 is equal to 3x. All right, so because there's a domain, we're going to find all of those angles. All right, so like the ones we did originally, we're going to find every angle that this is talking about. So sine is positive and in the first and in the second quadrant. Okay, and this is going to be our first rotation. So root 2 over 2, that's going to be our pi over 4s. So pi over the 4 in the first is pi over 4. Pi over 4 in the second is 3 pi over 4. Now, to get the following rotations, we're going to add 2 pi. We had been dealing in degrees, so we added 360. So we're going to add 2 pi to get my answer. So 2 pi would be 8 pi over 4. So pi over 4 plus 8 pi over 4 is 9 pi over 4. And 3 pi over 4 plus 8 pi over 4 is 11 pi over 4. All right, if you're stuck, just think about it as like 1/4 plus 2. Like what would you get if you added that? 2 1/4 or 9/4. All right, so those are my angles in my second rotation, and then we'll add 2 pi one more time to get our third rotation. So 9 pi over 4 plus 8 pi over 4 is going to be 17 pi over 4. And 11 pi over 4 plus 8 pi over 4 is going to be 19 pi over 4. And here's a little other like neat little trick that I've learned. The distance between them is the same. So if there's pi over 4 to 3 pi over 4 is 2 pi over 4s, then these two will all be the same width. So there's a couple of different ways to think about it if the fractional thing is not happening for you. So all of these are going to be equal to 3x. So I'm going to solve for x. I don't want 3x, I want x, and we should be pretty good to go. All right, so we're going to have 6 answers here. Yeah, 6 answers. So pi over 4, 3 pi over 4, 9 pi over 4, 11 pi over 4, 17 pi over 4, and 19 pi over 4 is equal to 3x. And everything is going to get divided by 3. All of these guys, divide by 3, divide by 3, divide by 3, everything. So pi over 4 divided by 3 is pi over 12. 3 pi over 4 divided by 3 is 3 pi over 12, or pi over 4. So if you need to write it as 3 pi over 12, that's fine. Not a big deal. 9 pi over 4 is 9 pi over 12, which is going to be 3 pi over 4. And then I have 11 pi over 12. 17 pi over 4 over 3 is going to be 17 pi over 12. And 19 pi over 4 divided by 3 is going to be 19 pi divided by 12. So these all look really good. Okay, so this is x, and these are my answers. Oops, trying to make a box here with one hand. Looks great.